All right, so we've been learning about galvanic cells, which is also another way to say voltaic cells. And today we're going to look at what is electrolysis and what is an electrolytic cell. So let me just show you a simple picture first. On the left, you'll see a cadmium and a copper electrode voltaic galvanic cell. And as we see, the electrons are flowing from left to right. Because I have a voltmeter, this is considered spontaneous. Okay? But if you look on the right side, we have a power supply, and sometimes that'll also say a battery. And the minute you see a battery, what that is extra energy being put into that cell that is causing a reverse, notice a reverse in electron flow. If you would add this up, this on this side would be a positive 0.74 volts. On this side, going this direction, would be a negative 0.74 volts. So this is a non-spontaneous flow of electrons. This is an example of electrolytic cell. We are forcing the electrons to go in the opposite directions. It's not naturally occurring. So let me show you a different example of how that would look. Here's one that looks very different to what we are used to, in the fact that it's all in one cell. The very fact that it has a battery there tells me everything I need to know. But let me show you a little bit more. If I would look this up right now, that would be the result of my sodium being reduced. And this would be the result of my chlorine being reduced. The way that this is going, it looks like the electrons are being added to the sodium, right? The electrons are being added to the sodium, and it's leaving the chlorine. So this would actually be flipped, and it would become negative volts. So if I add that up, that would have a negative voltage, which would be non-spontaneous. So I know that the flow is going in the opposite direction. So if I ever had to talk about what direction it's going to go into, I could figure out, wait a minute, I should flip the sodium, and the sodium should be losing the electrons, and it should be flowing from right to left in this case. But that's not the case. Okay? So let's talk about our note sheet. You have three problems you have to be able to convert. Okay? And there's only one thing you need to know before we get going on here. And it is on the top of your sheet already. Okay? I have given you two relationships. One is that a mole of electrons equals a certain value, which is actually called Faraday's constant. It's this many coulombs. The other thing you need to know is that 1 coulomb equals an amp over 1 second. Or another way to think of it is amps equals coulombs per second. Okay, so by utilizing that, we can convert some really important kinds of pieces of information. So I have a little picture on the bottom left here, and what I have is I have an electrode on the left, I have a battery, and then I have a copper spoon. And notice that I have silver here as my solution. And what this is really doing is that I'm plating my spoon and making it silverware. So it says, how long must a current of 5 amps, that's amperes, be applied to a solution of Ag plus to produce 10.5 grams of silver metal? I want to plate 10.5 grams of silver metal. How long will that take me? Okay, so as always, we start with what we know, what I want to find out, which is time and the fact that I want 10.5 grams of silver. Now, this is simply about converting. Be smart about this. It is still all about units. So I look up the molar mass of silver. Whenever I put a molar mass, I put moles. Immediately I want to put moles down here. And here's the trick for you. When you write moles again of an element, you'll probably in electrochemistry comparing it to how many moles you are losing. of electrons. So 1 mole of electrons. Why? Because there's 1 plus right there. All right, too far. So there'd be only 1 mole. If that was a 2 plus, that would be 2 moles of electrons. Hope that kind of is a good visual. Then I'm going to put the moles down here. For every 1 mole of electrons, I'm going to have 96,485 coulombs. Move all this over a little bit. Then I bring coulombs down. It says, here's the trick, 5 amps. Okay, well, check out this relationship right here. If 5 amps, I write it down here, is present, that equals coulombs over seconds, right? Coulombs over seconds. So I'd have 5 coulombs for every 1 second. That's what that would mean. It's one way to think of it. Well, I have coulombs on the bottom, so that's where I put the 5. And I'm going to have 1 second on the top. And now here we go for time. It didn't say how long necessarily, so you could actually answer it, but let's say we do this in minutes instead. You would actually have to be asked the amount of time, so maybe seconds was good enough, but if it were minutes, that's what I could write. And then I calculate it out. Got 31.3 minutes. That's how long it's going to take to plate that much silver onto my piece of metal. My spoon in this case. So the big key to this is to know the relationships of amps, coulombs, and seconds, which you don't have to have memorized. It'll be on your equation sheet, and also your moles to 96,485. FYI, sometimes it's actually written just like this instead. So you definitely could use 96,500 coulombs. That will also be given to you. Let's take a look at the next one. White gold is plated with rubidium in order to make it look more like silver. So it's not actually silver, it's fake, it's cheaper. How many coulombs of electricity must be pumped through the solution in order to plate 1 gram? Okay, so again, I want to start with the actual information I know, which is I want 1 gram. So what it's asking for is how many coulombs. Again, if you just allow units to be your guide, you'd be amazed at where we're going to go. We have to get to moles of electrons, so we have to get our compounds always into moles. So I look up the molar mass. I bring down 1 mole. And here's the key thing, it's very important. How many moles of electrons do I have? You have to find the charge. You need to find the charge. That's a 3 plus. It means it gives away 3 electrons. That's why it's going to be a 3. All right, I'm doing great because for every 1 mole of electrons, I'm even going to round this one this time, I have that many coulombs. And now I can calculate it. And I roughly get 2813 coulombs. Okay, so that's how much electricity, basically, I would need to plate that 1 gram. Okay? Last but not least. A current of 2.34 amperes is delivered to an electrolytic cell for 85 minutes. How many grams of AU from AuCl3 will be obtained? Okay, so that means I want grams, and what I have right now is actually time. Okay, amperes or coulombs are probably utilized in the middle of everything. So I want to start with my time. So I know, again, I see amperes, right? That's coulombs per second. So I need seconds. I need seconds. So there I go. For every 1 second, I have 2.34 coulombs. This whole little area right here is my amps. This is my amps, 2.34. So that's a way of writing it. I bring coulombs down in this case. That's the only relationship I know, and it always equals 1 mole of my electrons. Mole of electrons, let's move that away, equals moles of gold. Again, I want gold. So for every 1 mole of gold, how many moles of electrons do I have? Here's the key right there. I reverse cross, that reveals that it's a 3. And now I'm home free. Because I wanted mass. And then I just need to calculate that out. And I get 8.1 grams of gold. If I ran that for 85 minutes. Okay? I know we're still finishing up voltaic cells. You can definitely do that, but this will be helpful with your electrolytic conversions.